After 60 years, the era of general-purpose computing is ending. We are in a total transition, and the new era is being written by one thing: artificial intelligence. Jensen Huang says this shift, which they've worked on for over 15 years, is now revolutionizing every single layer of the computer industry: the chips, the systems, the software, the applications, all of it. But the biggest revolution is happening now in the physical world. This is where digital fuses with physical. This is where we finally supercharge the idea of a true, living digital twin. And it's all built on a single, powerful idea: the AI factory. Think about this. For 100 years, we built factories to make things: cars, equipment, products. Jensen's point is that those days are over. In this new era, every company will need the factories first. You'll still have your physical factory, the one that builds the car, but right next to it, you will need a second factory, an AI factory. This new factory doesn't have assembly lines. It has GPS. These are factories of intelligence. You apply energy to this computer. It runs an artificial intelligence model, and what comes out on the other end isn't a product. It's intelligence. It outputs tokens, a new kind of commodity, as measurable and valuable as kilowatt hours of electricity. This is the factory that builds the AI to drive the car. This is the factory that creates the digital twin of your entire production line, a perfect simulation that understands physics, chemistry, and biology, optimizing itself before a single piece of metal is ever cut. We are no longer just producing things. We are producing intelligence, and this machine, this AI factory, generates a commodity with tremendous value. This isn't just a new feature. This is the new industrial revolution. We are in a total transition. The new era is not about how fast a computer follows instructions. It's about a computer that writes its own. It's being defined by artificial intelligence. This shift is revolutionizing every single layer of the computer industry, from the chips to the software to the applications you use every day. But the single biggest revolution is happening right now in the physical world. It's where digital finally fuses with the physical. It is a concept that will supercharge the next 100 years of industry. It's built on a simple, powerful idea. Every company from now on will need the factories. For a century, you built one factory. It's the one you can see, the one with assembly lines, robots, and workers. It's the factory that makes things. But in this new era, that is no longer enough. You must build a second factory. This second factory has no assembly lines. It has no inventory. It's a factory of intelligence. Its machines are GPU clusters. Its raw material is the data pouring off every sensor, camera, and machine in your physical plant. This is the AI factory. You apply energy and data to this new factory. It runs an artificial intelligence model, and what comes out on the other end is not a product. It is intelligence. It outputs tokens, a new kind of commodity, as measurable and as valuable as a kilowatt hour of electricity. This AI factory is the engine. But what does it power? It powers the single most valuable asset your business will ever own: a true, living, digital twin. This isn't just a 3D model. A digital twin is a living, breathing, physics-based simulation of your entire operation. It's the ghost in the machine. Every time a valve opens in the real world, the digital valve opens. Every time a machine's temperature rises, the twin's temperature rises in perfect sync. And once that connection is live, the magic begins. Your AI factory starts feeding that twin. What's the benefit? It's not about saving a little money. It's about changing the laws of physics for your business. What if you could break your factory digital at 10,000 times a day, just to see what would happen? What if you could test a brand new production line, running it for a virtual year? Before you ever thought about spending $1 million on the steel, you find the bottlenecks before they exist. What if your digital twin, powered by your AI factory, told you that the main bearing on line for will fail in exactly 27 days? Not because it got hot, that's old news, but because the AI detected a microscopic vibration signature that no human could ever sense. Gartner reports that companies doing this are already seeing 20% reductions in maintenance costs and 25% boost in operational efficiency. This is the why. You are no longer just reacting to the physical world. You are predicting it. You are mastering it. So, how do you build it? This is where so many companies get it wrong. They look at the 200 people on their factory floor and think they need to hire another 200 data scientists. That's not the answer. You don't start with an army. You start with a skunkworks team. You need a new, hybrid skilled team of maybe 5 to 10 people. You need a simulation specialist who understands physics. You need a data engineer who can wrangle the data from your SCADA systems and your PLC system machines that are already running your plant. And you need an ML engineer who can build the models to connect it all. This is a small, focused, surgical team. The real question is the cost, and the answer depends entirely on your scale. Let's take a 200-person manufacturing company. You are not building a billion-dollar digital twin of the entire supply chain. You start focused. You build a twin of your single biggest bottleneck. Maybe it's one assembly line. Maybe it's your distribution center. You're not buying a supercomputer. You're using the cloud, the initial software, the data integration, the platform licensing. You're really looking at a project cost starting in the range of $300,000 to $400,000 for that first high-value process. That sounds like a lot until you realize that for many companies, a single day of unplanned downtime costs more than that. The cost of not doing it is extinction. Now, let's look at the 1,000-person company. This is a different game. You're not just funding a project. You are building infrastructure. You're not just solving one problem. You're building the factory for intelligence that will solve the next 1,000. You are building an on-premise AI factory. You're giving your new 10-person AI team their own developer-grade compute. But you're also making a capital investment. You are buying the DGX clusters, the supercomputer in a box. That is the new factory. Here, the starting cost for a full-scale, high-tech factory digital twin isn't for 100,000. It's a million-plus investment, and it goes up from there. The data integration alone can be 40 to 60% of the total cost. But the return is exponentially larger. Your AI factory isn't just predicting maintenance on one line. It's redesigning your entire product line in a simulation. It's optimizing your energy consumption across the entire plant. It's running what-if scenarios on your entire supply chain. 24/7. The companies that build the best physical factories will be efficient, but the companies that build the best AI factories will dominate because they are not just manufacturing a product. They are manufacturing the intelligence that makes the product, and in the new economy, that intelligence is the most valuable commodity on Earth.